Hello friends, I am Dr. S.K. Mittal. In this lecture, I have considered problem on driving point and transfer functions. One question I have considered in which driving point function is to be calculated. Driving point function is actually a network function where measurement of voltage and current are considered at the same point or same port. Therefore, if for this question a driving point function is to be calculated, then we will consider a voltage, and this voltage must be these 2 points, and one current will be flowing from this point to the rest of the circuit. And if we consider a voltage between these 2 points and current from this point, then the ratio of this voltage and current will nothing but the impedance of the total function. Therefore, if Zs or driving point function is to be calculated, means we have to calculate the equivalent impedance of the circuit. This question was asked in GATE 2014. Since impedance function or driving point function is to be calculated, or Zs is to be calculated, but see the circuit. In this circuit, there are 4 elements, 2 inductances, each of 1 Henry, and 2 capacitors, each of 1 farad. Since impedance is to be calculated, therefore, these inductances and these capacitances must not be in Henry and farads, but these must be in the form of ohm, because unit of impedance or driving point impedance function Zs is nothing but ohm. If in any question L Henry is given, then its equivalent ohmic value will be L into S. If C farad capacitor is given, then its equivalent ohmic value will be 1 upon Cs. Then to calculate Zs, what I will do, I will convert all the inductances and capacitor in terms of ohms. Then 1 Henry inductor will be 1 into S is equal to S ohm, and other inductor which is also of 1 Henry will be of S ohm. This inductor, its ohmic value I will represent Z1, and other inductance which is also of 1 Henry I will consider Z3. The capacitor is of 1 farad, therefore according to the formula 1 upon Cs, the capacitor ohmic value will be 1 upon S ohm, and this capacitor which is also of 1 farad, this will also be of 1 upon S ohm. Then to calculate the equivalent impedance Zs or driving point function Zs, I will consider Z1, Z2, Z2, Z1, this I will consider Z2, this I will consider Z3 and Z4. It is similar to the calculation of equivalent resistance. In calculation of equivalent resistance, we know that if we want to calculate the equivalent resistance between these 2 points, then calculation must be from opposite side. If we start calculation from opposite side, then we can say that this Z3 and Z4 will be in series. If Z3 and Z4 are in series, Z3 is of S ohm and Z4 is of 1 upon SO. And if Z3 and Z4 are in series and its equivalent impedance I will consider Z5, then Z5 will be S plus 1 upon S, and if I solve, this will be S square plus 1 divided by S. Now Z5, which is the series combination equivalent of Z3 and Z4, will be S square plus 1 divided by S ohm. Now, to calculate further Z3 and Z4, I will replace by Z5. To see the circuit, this is Z1 of S ohm, this is Z2, and this Z3 and Z4 I will replace by Z5, the value of which I have calculated in equation number 6. Then, see this, Z3, Z4 I have replaced by Z5. Now, 1 upon S I have represented by Z2. Then see the circuit, if you see, then Z2 and Z5 are in parallel. So, Z2 and Z4 are in parallel, and if its equivalent I represent by Z6, then Z2 and Z5 equivalent will be Z2 into Z5 divided by Z2 plus Z5. Therefore, Z2 is equal to 1 upon S. Z5 I have calculated in equation number 2, and this is S square plus 1 divided by S. So, it will be S square plus 1 divided by S. It is the value of Z5. Then Z2 1 upon S plus Z5 S square plus 1 divided by S. Then what will be the value? In the numerator, S square plus 1 multiplied by 1, it will be S square plus 1. S multiplied by S square, it will be S square divided by, since the denominator are same, then I can say 1 plus S square plus 1 divided 1 plus S square plus 1 divided by S. Now, it is the value of Z5, Z6. If I solve this value, then it will be S square plus 1 divided by S square multiplied by S divided by S square plus 2. Then it will be equal to, means Z6 will be equal to this S will be cancelled, and it will be S square plus 1 divided by S, 1 S will be cancelled, so it will be S multiplied by S square plus 2, or if you want to simplify, then Z6 is equal to S square plus 1 divided by S cube plus 2S. In this way, the combination of Z2 and Z5 which are in parallel I have represented and calculated as Z6, and Z6 value is represented in this equation S square plus 1 divided by S cube plus 2S. Now, what I will do next, Z2 and Z5 I will replace by Z6. So see, I have drawn the circuit. Z1 is S, Z6 I have calculated. Its value is S square plus 1 divided by S cube plus 2S. Now, see the circuit. If we look between these two terminals, Z1 and Z6 will be in series. Therefore, Zs is equal to Z1 plus Z6. it is equal to S plus S square plus 1 divided by S cube plus 2S. Now, after solving, the value of driving point function Zs is equal to S to the power 4 plus 2S square plus S square plus 1 divided by S cube plus 2S. Now, the last answer will be S to the power 4 plus 3S square plus 1 divided by S cube plus 2S. In this way, I have calculated the value of Zs, and value of Zs is equal to S to the power 4 plus 3S square plus 1 divided by S square plus 2S. So this is the way in which we can calculate the driving point function of any network. Thank you.